Hello student, welcome to the online tutorial session. Today we will finish the last part of this chapter, number 4, the local area network. So today's topic is connecting the LAN segments. Okay, so in a large organization, there are several departments doing the different type of work. For example, an engineering firm may have an engineering group, purchase group, a sell group, etc. And moreover, these departments may be distributed over the different floors of building. Again, a large university may have the different departments based on the subject taught and the research done. So to put all the different work groups together, one can simply put them on the same LAN and let them communicate and interact with each other. Okay, so to develop such kind of a communication, so what we require? Okay, so we require that different type of LAN connections. Okay, or you can say the LAN segments. Okay, so two or more LANs are connected with each other using the connection devices like intelligent and devices are there. So what are those devices? So bridge, switches and routers are such devices used for linking different LAN segments together and restricting network traffic within the different LAN segments by effectively dividing the whole LAN into a separate broadcast and the collision domains. Okay, so we will learn about the bridge first. Okay, you are able to see the picture of the bridge over here. Okay, so first we need to understand the meaning of the bridge. What is bridge? Okay, so a bridge is another device used to connect the different LAN segments while passing only a certain specified traffic between them. Okay, so a bridge consists of two or more ports. Okay, where each ports connect to a different LAN segment. So what is the purpose of using the bridge? Is what? That breaking the larger network into the smaller segments. And number two, connecting the different media types such as connecting UTP with the fiber optics or connecting different network architectures such as connecting Ethernet with a token ring. Okay, so we actually don't know what kind of a LAN segment LAN 1 is using and LAN 2 is using. That's why they can use a different type of technology, topology also. We are connecting, or they can using different kind of a cabling also. So we are connecting those small LAN segments through this bridge. Okay. Now there are different three types of bridge is available. That is local bridge. You are able to see the picture. Okay, so the bridge connects two LAN segments directly. In Ethernet implementation, it is known as the transparent bridge. In a token ring network, it is called the source routed bridge. Okay, so this connection is built on between two LAN segments. Now coming to the third one, that is a remote bridge. Okay, so this bridge is connected with the another bridge over a WAN link. Okay, so one bridge is there, one bridge is connected with the other one. Okay, and now coming to the wireless bridge, this bridge connects with another bridge without using the wires. Okay, so here one bridge, in case of wireless, you are able to see from the name you can determine that one bridge is connected with the other one but without using any kind of a cabling. Okay, any kind of a wireless wire. Okay, so it is also use radio signal. So if it is a wireless one, there is any connectivity they have to use to send the signals, so they are using the radio signals to connect. So in OSI layer, that in TCP/IP network models, the functionality of the bridge are defined in the physical layer and in the data link layer. We will discuss about the OSI model and the TCP/IP protocol in the next chapter. That point of time, you are able to understand what is the link layer, what is network layer, all those. Okay, so just like bridge no longer used in the computer network, bridge has been replaced by the switches. So previously we are using the bridges, now it has been replaced by the switch. Okay, now Our next topic is repeater. Okay, so a repeater is basically used to boost or amplify a signal while it travels across a network. Okay, so actually this repeater operates in the physical layer of this OSI model, or we can say TCP/IP protocol. Okay, so what is its job? Its job is to generate the signal over the same network before the signals become too weak or corrupted, so as to extend the length to which the signal may be transmitted over the same network. So sometimes it happens that uh, when we are getting the signal, signal become noisy, corrupted, or faint. Okay, very small signal, very thin voice of a thing. Connection is coming, network problem is somewhere that you are calling someone and you are not able to hear the voice clearly. Okay, it may have happened, or just there's an ambiguity in the call, because you are not able to understand. You are able to understand that people are saying something, but you are not able to recognize what actually the person is saying to you. So this kind of things are actually why, just because of weak signals. So whenever the signals are tends to weaken, that point of time it boosts or amplify the signal. Okay, so thus it is used to extend the LAN segment without any data. So this is usually there is usually two port devices which connect an incoming cable with an outgoing cable and allow the data to move from one segment to another segment. Okay, and as you see, there is a annuited signal and repeater is there. There is a distortion is there. When the first signal you are able to see this one, there is a distortion. First high, then the high bump you are able to see this one. It's lower down. Again it is lower down. Again it is lower down. Okay, the high altitude, the high magnitude one is again lowering down continuously. So does it means that the signals become weakening? So that point of time, what it will do? A repeater will boost the signal so that all the high bumps are, or high magnitude amplification one remains same. Okay. An example that is 10 base 5. Okay, Ethernet network actually using this. A maximum length of this is up to 2460 meter is possible using the repeater. Okay, with the total of 300 nodes on a whole. Okay, now okay, now moving to the next one, that is switches. Okay, so a LAN switch is similar to a multi-port bridge and can be used to link computers or several LAN segments. Okay, whereas bridges are usually connect to network segments, switches are usually used to connect the single computer. Just like a network hub, a switch is just physically configured like a hub and functionally behave like a bridge. You can say it is the amalgamation of a hub and bridge. Okay. Um, so how actually switch working? So based on the MAC address of the destination node, a switch make a temporary connection between the source and the destination port. Okay, then it forwards the data frame from one source port to the destination port only. So the connection is terminated when the transfer is over. So you're able to understand, suppose when in earlier days how actually telephonic conversation is made. Okay, when actually the server is there. Okay, the source and destination is there are different port plugging type of switch is there. Okay, okay, you know that AV port in your TV. Okay, where you have to couple you have to couple the cable where from the set-top box the cable is coming. Okay, that one, that type of a thing is there. Okay, when there is an incoming call is done from one point of time to one, so they will detect that this signals is having which destination. Okay, so they will detect, and then they will build up a connection. How they will build up connection? Like there is a I have said that there is a AV port and then you have to put a cable. Like this kind of a similar thing. They will find out the destination and let in this particular port or switch, you can say. They will put the cable and the actually initially and not a permanent one. Okay, a temporary connection has been built. Okay, as soon as the call is over, okay, then temporary connection is again released. In this way, actually, switch is working. Okay. Okay. Now coming to the router. Okay. So the router connects a different network segment. It switches the data packets between those networks which are either located in different local segments or built with a different network layer protocols. So that different line segments can be built on depending upon the different line protocol, different protocol, or also they can be use different network layers protocol also. Okay, so they actually build this connection between those. So when router receives the data packet on any one of its interface, it checks the destination address of that packet based on the destination address, and then it forwards the data packets from one interface which is connected with the destination address. To forward the data packet to its destination, router keeps the record of the connected network. Okay, so routing you are able to understand very good with the example of the Google Map. Okay, so how? See, from your location you are searching your destination. Okay, so in your location part you are giving the location, and in your destination part you are giving, okay, the destination address. And then in the Google Map you are actually, Google Map will do what? Google Map will provide you uh, 2 to 3 at least the probable pathway through which you can reach. Okay, and they also measure you the amount of time or amount of destination is there. So they will Google Map will direct you to the shortest path. Okay, the shortest path means maybe they will detect the 3 paths, but they will actually promote the shortest path to you so that you can go. So what actually routing do? Okay, so routing will do, as you know, the informations in the network are passing through a packet. Okay, so one after another, one router's job is to hold the packet and find out where is the destination. Okay, and destination they will address first, and they will check that through which pathway, if we want to transmit the data packet, so the data packet can reach the earlier. There may be 4 to 5 routers are waiting in this particular network to transmit the data packet, but it will choose the shortest one, okay, so that it can be easily transferred, so that the transmission can be smoothly done in a quick time. Okay, so this is actually the example of a router, you can say. Okay, and also there is a routing table also there. What is routing table? That which router, suppose router 1, router 2, router 3, 5 routers are there, router 5. So after router 1 receives the data packet, it is transmitted to the router 3. Why they are escaping number 2? Because okay, with the help of a diagram, if I explain, that will be better. Suppose my source point is this one and my destination point is this one. Okay, I having here one router, another router, router 3 over here, router 4 over here, router 5 over here. Okay, so what to do? There is a different pathway is there. So from the source end, sender is sending this packet. So again it is going to the further to R1. Okay, maybe it can be go to R2 also. Okay, it can go to R1, it can go to, suppose it received by the R1. So after reaching it to R1, it will detect the pathway. Okay, so in the table, there will be a table with a router 1, router 4 names written over here, and which data packet it when received, it will be there. Okay, from R1, it is maybe goes R1 will choose that it can passes through the packet to R3, it can passes to the R5 as well. Okay, so let's the distance between R1 and R3 is more, or some time will be there or something, or there is any transmission is going on. That's why R1 chooses R4. So from R1 there will be updated table, the packet is received by the R4. Okay, then there is a probability that R4 can directly send it to the destination end, or if there is any problem, then R4 will update it to R5. So if it is directly, then from R4 to directly it will be passed to the destination, it will be updated in the router table. Or otherwise, what will happen after R4, the packet will reach to the R5, so it will be updated in the table, that from R1 to R4 to R5, and then it is received by the destination end. Okay, so this is actually the question of actually how the routing table works. It will track the data packet from which routers to which router is actually moving. Okay. So its definition is there that to forward the data packets to its destination, a router keeps a record of connected network. These records are maintained in the database table known as the routing table. So routing table can be built statistically or dynamically. So what actually basically the router is used to connect the different network segments, to connect the different network protocol, okay, to connect the several smaller network into a larger network, or that is called internetwork, to break the large network into a smaller network, or to connect the two different media types such as UTP and fiber optic cable. Okay. Now we are moving to the next topic, that is a gateway. Okay. The term gateway is used to describe a broad category of a LAN interconnecting devices. So which is basically acts as a translator between two networks running totally incompatible communication protocols. Okay, what is incompatible communication? For example, one is following, that is like TCP/IP is one, and another one is IBMS system network architecture, or SNA in another. So one system or one part is actually following the TCP/IP protocol, another one is following the SNA protocol. These two are different. Okay, so what actually gateway will do? Gateway will actually work as an intermediator, or translator, or intermediator through which, okay, it will translate. So a good example is that when you actually transfer amount in online using your credit card or debit card, you will see there is a payment gateway is coming. Okay, through a payment gateway, it is not that actually they will give you their bank details and everything in a website. No, there is a payment gateway will be there, and that payment gateway you have to put your card number, expiry date, and all the details, and then it will pay. So what actually this payment gateway do? The payment gateway is work at an intermediate. Why actually? Suppose my account is having in HDFC, and the website owner, where actually we were working and we were actually placing the order, they are having different connectivity between banks or something. Okay, so they are having a different terms and condition or agreement, something like that. So what will it may be? It maybe there is no agreement between these two banks or something can happen. So what will happen? The gateway will act like a security guard. Okay, so first from the customer it will take the payment. Okay, it will keep in his bank, and then from his bank it will transfer to the owner where actually you are placing the order. So why it is happening? So it will reduce the security, reduce, not will reduce loopholes of the security. It will reduce the loopholes of the security. And one more thing, this problem may arise in Google Pay and Phone Pay. You are saying that transaction cannot find, it is lost somewhere. Okay, it is stuck somewhere. So this kind of a problem, okay, you can omit. Okay, using this gateway. So I am from the point of view of payment gateway I am saying, but in case of network also, if two networks are following the different protocol, so they will not set to an agreement because they are following different internet protocols. So what will happen? So there must be a one intermediator or translator is there where this coming through this particular medium the transmission can be possible. So in case of memory, you remember that we require buffer memory. Why? Because there may be a speed misparity is there that's coming on this money. The data is coming in a very speedy manner, but output is not going in a same manner. So that point of time we require a memory buffer to neutralize the speed, because the input stream is coming in very fast, the output stream is not going on. There will be a misparity. So what we will doing, we are keeping this part of the memory which is not out for the output session, we are keeping in a buffer memory. So exactly work of a buffer memory and this gateway is same. Okay, so a router only checks the addressing information in the data frame at its handle, and it does not change the content of the message. However, if the destination nodes differ in the protocol standard, unlike a router or gateway repackage, and sometimes it converts the data to the destination network. So what type of function actually doing? Default gateway, some networks can have multiple routers that lead to other networks. So among this, one router can be selected to serve as a primary path to other network. Okay, so this router is called a gateway, a default gateway. Now electronic mails gateway, emails gateway are translated message from one vendor messaging to application to another. Suppose you are having your account in your Gmail, and you are sending the mail to the account holder having the mail in the Rediff mail or Yahoo mail. So both are not belongs to the same category. The different network they are using. So what will happen? They will not send the mail. There must be some sort. They are more maybe following the different protocols, but we need to send this information. So this way intermediary works. Okay. Application, so that the user of the different email application can share their message. And firewall gateway also serves as a firewall which allow the internal network, that I am talking about the security one, that is okay, user to access the internet. So while block the internet user from accessing the internal network. So directly you cannot choose. There is a protection is there. If you pass this gateway, then only the message can move to the another end. Okay, and proxy server, the gateway may act as a proxy server. This make the copies of incoming and outgoing data packets and forward them to another site. Okay. Now coming to the differentiation part. So bridge and repeater. So repeater actually a bridge use, suppose LAN segment separate to LAN segment, and repeater you use in extended LAN segment. Okay, in case of bridge, filtering of data take place across a bridge. In case of no data filtering takes place in case of repeater. Okay, bridge uses a MAC address of the nodes to filter the data, and repeater does not require any kind of a MAC address. Okay, nodes on the either side of the bridge fall under the different collision domains, and nodes in the either side of the repeater falls under the same collision. It is comes under a different collision domain. Now differentiation between bridge and switches. Okay, so basic, that is a bridge can connect the fewer lines, and switch can connect the more networks compared to the bridge. Buffer, so bridge says do not have buffer, switch has a buffer for each link connected to it. Types, simple bridge, multi-point bridge, and the transparent bridge are there. And here the switch, store and forward switch, and cut through switch is there. And error, bridge do not perform error checking, but switch performs the error checking. Also, in case of switch, faster operation than a LAN bridge, and slower operation than LAN bridge. In case of bridge, I am talking about. Okay, no switching operation is present in bridge, but a fast switching matrix is used to connect the nodes involved in a data transfer. Now the difference between router and the bridge. Okay, so router operates on the network layer of a OSI model, and bridge operates on the data link layer of the OSI model. The router used to connect the LAN and WAN, and bridge used to connect the two different LAN segments only. The router transmits the data in the form of packet, and the bridge transfers the data in the form of frames. Okay, it reads the IP address of the device, and bridges reads the MAC address. Okay, and the router has more ports compared to bridge, and bridge has only 2 ports. It uses a routing table for sending data in case of router, and bridge does not have any kind of a routed table to sending the data. It works on more than the broadcast domain. It works single broadcast domain. Okay, thank you, student. I'm ending my lecture over here.